In this video, we're going to take a look at some properties about parallelograms. The shape that I have displayed is a parallelogram. If I was going to name this shape, this is one correct way that I could label this. It would be parallelogram ABCD. An incorrect way to label this would be parallelogram ACDB. And that one is incorrect, and it has nothing to do with the fact of not being in alphabetical order, but it's the order of the letters. It does not matter which letter of the parallelogram you start with, but you need to list them consecutively. And it does not matter if you go clockwise or counterclockwise. So one more correct example could be, let's start with C. We'll do C, B, A, D. Those letters are in consecutive order. I also have segments drawn in my parallelogram. I have segment AC as well as segment BD. This is what we refer to as the diagonals of the parallelogram. Okay, here's our definition of parallelogram, as well as 4 properties of the parallelogram. Properties are true facts about any parallelogram. It's not its definition, but they are true facts. So please don't confuse a property from the definition of the shape. And I'm going to demonstrate what these properties are referring to. Okay, so in my first example, once again I'm just going to tell you this is a parallelogram. There is a property that says opposite sides are congruent. That means the top side should have a length of 48, and this side on the left should also have a length of 37. That's what we consider to be opposite sides. There is also a property that states opposite angles are congruent. I'm going to start with this 70 degrees. This angle in the upper right-hand corner, that's considered the opposite angle. It would also have a measurement of 70 degrees. There is a third property that states that 2 consecutive angles in a parallelogram add up to equal 180, or they're supplementary. So this new angle in the bottom right-hand corner, it could be considered consecutive with the 70 that's in the upper right-hand corner, or it's consecutive with the 70 in the lower left-hand corner. These angles are supplementary. My missing angle should be 110 degrees. And this property is developed from the definition. Keep in mind that a parallelogram has 2 sets of parallel sides. If we refer back to parallel lines in a transversal, I'm just going to kind of put a line in there. My 70 degrees and my 110 degrees were considered consecutive interior angles, and we learned in the past that those should be supplementary. The only other missing angle in the picture is in the upper left-hand corner. It's opposite the 110 degrees, so it's 110, or it's consecutive with the 70s. Okay, in my next example, I gave some lengths of segments, so I'm going to put these ones in, showing the opposite sides of the parallelogram. In the picture, the value 8 is only part of the diagonal line. There is a property that says the diagonals bisect each other. Here's what that means visually. Within one diagonal line, the other one's going to come through and bisect it, which means this missing side, or length, should be an 8. As well as if I look at the other diagonal line, it is also being bisected. So this missing value should have a length of 12. In the last example, we're just going to try to find as many missing angles as possible. I can start off with using prior knowledge. Here's vertical angles, and I have linear pairs. My 30 degrees, This 30 degrees isn't considered opposite, and I'm going to put a mark here with this other angle. Those are not considered opposite angles in the parallelogram. The diagonal lines are causing more angles this time, so I would not want to write 30 degrees down there where that mark is. However, I'm going to refer back to its definition. If my top and bottom sides are parallel, then the red line that's coming through would be a transversal, which means I would have 30 degrees in this lower left-hand corner because I have alternate interior angles. The other angles I could find is based on the fact that 3 angles in a triangle add up to 180 degrees. I could find these angles to be 50. I have 4 more angles that are left. The only thing I know about these angles, and also referring back to its definition, because the left and right side are also parallel, these would be alternate interior and should be the same number. However, there's not enough information in this picture. Don't assume those are each 50 degrees. We can assume that those diagonal lines are bisecting the corner angles.